classmates here? They're not paying attention. All right, so this is a generalized flow of the circulatory system. It's really generalized. It's mainly just to show you kind of the way that it would flow around without the complication of where the vessels actually come off. I will show you that in a little bit. Let me back out just a little bit further so that maybe you can write this down in your notes first. Oh, I guess I need to be even further. There you go. All right, so you can stop it and go ahead and take notes. To continue on though with the discussion, okay, so if I've divided the heart into 4 general places, I have the right atrium, which is on the right side of the body. So this is like if you were looking at the body laying down on a table. All right, so you got the right atrium, you have the right ventricle, you have the left atrium and the left ventricle. All right, so the general flow is into the heart from the systemic circulation via a very large vessel called the vena cava. The vena cava will bring blood into the right atrium. That will then go to the right ventricle, and it will be pumped out via the pulmonary artery. Arteries are always leading away from the heart. Right at this point, the blood is very CO2 rich, and it is going to go to the lungs. It'll go to both the right and left lungs, and of course I'm skipping all the names of the different arteries that are going to the right lung and the left lung, and they will go down into smaller vessels called capillaries, but eventually it'll be the capillaries surrounding the alveoli, and those will be doing the gas exchange like we were just talking about a minute ago. And then it returns to the heart via the pulmonary vein. I just erased oxygen rich is what that should say. And so the blood is coming into the left atrium, going to the left ventricle, out the aorta. Now it branches really quickly into other vessels that are going to the head and to the lower part of the body. And the fairly large vessels are called arteries. Then you're going to narrow down eventually to arterioles and then to the capillaries that are feeding the cells. In the capillaries, the cells are going to be taking up oxygen. They are also taking off nutrients that might have been picked up by the digestive system cells and distributed to the bloodstream. And the cells themselves will be getting rid of nitrogenous waste and carbon dioxide. This is going into the capillaries, or that is into the blood, and the capillaries will go back to the venules and to the veins. Just by the way, just this setup here, I have the largest things on this side and then the smallest things over here next to the cells. All right. So then we're going back to the heart and starting our circulation again. So all the way around and over here. Now the nitrogenous waste that got picked up from the cells and into the bloodstream, those would be going to via the circulation. So they're coming all the way back around via the capillaries in the Bowman's capsule. Is going to do the nitrogenous waste removal like we talked about with the kidney. Carbon dioxide, of course, is going out the lungs. So those are those 2 waste products that would go out. Now, any nutrients that are not used in the bloodstream will then just return and they keep circulating until the cells, until they hit all of the cells and it's taken off or it's stored somehow. So that's in general, that's the circulation. All right, so that's not really how it goes. So let's just look at another. This is kind of generalized too, but at least it's a little bit more true to what it actually looks like. Notice the atrium here. It's actually receiving blood from the bottom and from the top. And in this case, they're calling it posterior and superior. No, they're calling it anterior and posterior. Sometimes it's superior and inferior, depending on the source that you use. But anyway, from the top, from the bottom, coming into the atrium, so you can see it's not just one thing that's coming in. And then it's going to the ventricle, and it's going out of the ventricle, not on the side like I had it drawn in the other diagram, but literally up and to the lungs. Okay, so it's going to the right lung, into the left lung, and it will then come back to the heart into the atrium here. All right, then it's going to the ventricle, and out the aorta, where it immediately splits into the vessels going up and down. So again, that's generalized, but at least you can kind of see the heart in a little bit more true to form. Now there are, as we were talking about before, in different organisms, different numbers of heart chambers. So if you look at this one, this is talking about, so like in a fish, for example, I just have the heart pumping blood that is going past the gill, and on the gill it's going to be picking up the oxygen like we talked about, and then pumped around to the body cells. All right, so it just has two chambers, one for entry, one for exit. Entry is atrium, exit is ventricle. All right, so in the amphibians, what they have is they have an entry place, in other words, coming in, and then they have an exit towards the lungs, if they have them, or to the gills if they don't, and then it's coming back. But in this case, there is no septum between this blood that's going this way and this blood that is coming back. So what that means is that blood could mix, and it's not as efficient as it would be if they were completely separated. Now, in reptiles, they have a partial separation. So sometimes they're called 3.5 hearts. By the way, I forgot to say this is 3. So 1, and then this is 1 ventricle, 2, and the other atrium. So that's 3 chambers. Reptiles have something, sometimes people call it 3.5. Really, it's kind of like 3, but the septum is sometimes complete or sometimes just a half one, but it keeps the oxygenated and deoxygenated blood a little more separate. Here's the septum down here. But the other thing it has is a subcutaneal passageway. That's this one. That's for when reptiles are kind of dormant or in torpor, and especially like if it's super cold, they'll just shut down and not use their lungs. All right, so that's kind of a specialized situation. And then of course chordates are just like what we've been talking about. All right, now the real heart parts, you should know most of these chambers, but you can see that there are some, this is not focusing great, I don't know why. You can see that there are some, trying to get it to focus better. Okay, that's better, isn't it, a little bit? All right, so you can see that there are some other names of things, but basically the flow is the same. So posterior vena cava, anterior vena cava, coming into the atrium, going around, and anyway, the flow is the same. This is just a larger view, but you can see the aorta is very large up here and separating into the arteries that are going off in the different directions. All right.